So for example 10, we are going to go back to two-way frequency tables. Remember that a two-way frequency table takes two different sets of information and compiles it into one table. So we have the age of the students across the top and the gender of the students along the side. And the first thing we're going to do is go ahead and complete this table by finding subtotals and the grand total. So we have 20 students who are between 18 and 20 years old. We have 16 students who are 21 and older. We have 18 male students. And we have 18 female students. Remember that the total should be the same whether you add down 18 plus 18 or across 20 plus 16, and those do both add up to 36. And that's confirmed. Up here it tells us that he has 36 students in his class. So we know we're on the right track. So we're going to begin with some probability that we have done before. So it says first to find the probability that a student at random is 18 to 20 years old. So I'm going to just name that the probability of 18 to 20. And again, I know I have 36 students in the class, so it's going to be out of 36. And for 18 to 20, I want all students. There's no gender specified. So I'm going to take the total number of 18 to 20-year-olds, which is 20. Now 20 over 36 can be reduced. If I divide them both by 4, 20 becomes 5, and 36 becomes 9. If you guys remember when we do ninths, we know it's going to be whatever the numerator is repeating. So this is 0.55555 repeating. We would abbreviate that to 556. I'm sorry, estimate, not abbreviate. Or 55.6%. In the next one, we're getting a little bit more complicated. We want female or 21 or older. This is going to be using the addition rule. I'm going to just use an F for female, and then my or sign, and 21 plus. So the first thing I want to do is find the probability of randomly selecting a female from the class. That is out of 36, and according to our table, there are 18 females. So I'm going to use my green here. Oop, that's getting low. I better sneak up a little bit. 18 girls in the class. Then I want to add to that the probability of selecting a student who is 21 or older. That's still going to be out of 36. And that subcategory here is 16. So we have 16 out of 36 students. And finally, I have to remember that with the OR rule, we have to remove duplication. So I'm going to subtract the probability of a student who is female and 21 or older. I'm going to find this number by looking at where these two overlap in the table. So when I look over here at my table, I see that 21 and older and female both share this 8. So we use that 8 once in my 16 calculation and again in my 18 calculation. So we got to take that out. There's just one too many 8s in there. So because they all have the same denominator, we can go ahead and add straight across. So 18 plus 16 is 34, and 34 minus 8 is 26. And so I'm going to have 26 out of 36, at which point I'll go ahead and put that into my calculator and let it do the calculation, the reducing, and all that good stuff for me. Remember that when you put it in your calculator, if the fraction can be reduced, it will automatically reduce for you. So hopefully you guys can see that. It's awfully sunny in here. You can see that it's reduced down to 13 over 18. And then we can convert that to approximately 0.722 or 72.2%. Now we're not finished with this example, but this is getting to be a lengthier video, so I'm going to stop there and I'll start another video picking up at example 10C.